Hey guys, Mr. Shaw here. We got to talk about some square roots today. Now again, this video is going to seem kind of out of place because we've been talking about quadratic functions and now I'm kind of throwing in some square roots. We have to review some square roots before we go on, because a lot of the stuff that's coming up, like the quadratic formula, complex numbers, all that stuff is very heavy on square roots. So we're going to take a break and we're going to kind of talk about more square roots in this case. And I got to tell you what, I got to get this video done because my fiance is going to kill me. I got to get home. All right, here we go. Let's get to it. In this video, you're going to learn three things. You're going to learn about how to simplify radicals, how to multiply and divide with radicals, and then how to rationalize denominators. We'll throw in a little bit of adding and subtracting in there as well, if we have time. Now, first thing you need to know is that a square root can be simplified, or it is simplified, if there are no pairs of factors underneath the radical. Now again, I'm going to say pairs of factors, or let's say or perfect squares. And we'll look at that in a second. And now it says there is no fraction under the radical. Okay, we can't have that. And then there is no radical in the denominator. Okay, now again, it really doesn't matter if the radical is in the denominator. It's not bad or anything. Like your Algebra 1 teacher might have told you it was bad. It's not bad. We can deal with it. But the thing is that we need you to be good at rationalizing the denominator, and that's what that means. So we'll get into it. So let's look at first just simplifying. Now, before I even start this, I want to talk about perfect squares. All right, so again, the perfect squares are as follows. Okay, now these are numbers that you are going to get. Again, it's going to be when you multiply a number by itself. So for example, 1 times 1 is a perfect square, 1. 2 times 2 is 4. 3 times 3 is 9. So on and so forth. 4 times 4 is 16. 5 times 5 is 25. 6 is, whoops, of course I just did that. Okay. Whoops, of course that just happened. Here we go. Sorry, real fast. 9, 25. Nope, 9, 16, 25, 36, 49. Again, so 6 times 6, 7 times 7. 8 times 8 is 64. 9 times 9. So on and so forth, is 81 and 100. We'll stop there for now. We need to probably know all the way up to 15. Actually, I guess we'll just put it down there anyway. That's fine. So it's 121 for 11, 144 for 12. That's 44, not 94. Okay, 169 for 13, 196 for 14, and 225 for 15. All right, so here we go. Now what we're going to do is we're going to start with just doing the factors. All right, so again, factors of 48 are 1 and 48. Again, that's a 4, not a 9. 2 and 24. 3 and 16. 4 and 12. And 6 and 8. Now I'm looking for the highest perfect square that I see on this list. Again, these are all the perfect squares. Again, I'm looking. You want to start kind of at this side, again, with the bigger numbers. So 48's not, 24's not, 16, boom, right there. Okay, so that means that we can break this down into the square root of 3 and the square root of 16. And we know that the square root of 16 is 4. All right, so now this square root of 48 will break down into 4 square root of 3. And that's just your answer. Let's keep going. Again, 300. So with factors of 300, I'll do them down here just because we're kind of out of room. Okay, so factors of 300 I've got are 1 and 300, 2 and 150, 3 and 100. Now, I know 100 is a perfect square, so I can actually stop. Now, the reason I can stop is because again, I can do 4. 4 might work, I don't know, but again, it doesn't matter because it's not going to be higher than 100, and I need the highest one in order to simplify things a little bit. So I'm going to use 3 and 100. So let's break it down into the square root of 3 and the square root of 100. Square root of 100 is 10, so we can rewrite this as 10 times the square root of 3. Let's keep going. Next one, we've got 5 times the square root of 98. So let's go ahead and do the factors of 98. Now you see this 5 outside. Again, whatever we get, again, we're going to have to deal with that. Whoops. Okay, we're going to have to make sure that whatever we get out of the radical, we have to make sure to multiply it by 5 at the end. So let's go ahead and do factors of 98. So I've got 1 and 98, 2 and 49, and I can stop again because all my perfect squares, you see that 49's on it right there. Okay, so that's going to be 7. The square root of 49 is 7, so let's break it down. So this will break down into the square root of 2 and the square root of 7, or sorry, square root of 49, which is 7. Now I have to make sure to multiply these guys together, so 7 and 5, because they're both going to be outside numbers. Let me rewrite it for you. So it'll look like this: 5 times 7 square root of 2, and you would just want to make sure to multiply those. So it'll be 35 square root of 2. Perfect. All right, let's keep going. Now we're going to talk about multiplying. So basically the easiest way to remember, guys, is that you multiply, again, this is going to sound silly, but you multiply the things on the outside and then multiply the things on the inside. That's it. That's all there is to it. Okay, and then the last part is that we have to make sure that the things that we're real mathematical here right now. The numbers underneath the radicals and if any variables are underneath the radicals, we need to make sure that those are simplified as well. All right, so let's do it. Again, you see here, inside I have the only number on the outside would just be like 1s here. So 1 times 1 is going to be 1. So we don't even need to worry about it. I don't even know why I put them there. All right, so and then we're just going to multiply the insides together. So 3 times 12, okay, is 36. So this will be the square root of 36. And we know that square root of 36 is 6. That was easy. All right, and now we can do the same thing here. I tell you what, let's get our handy dandy calculators out, and I'll just pull mine up on the screen. All right, so this will be, it'll be 18 times 25, so 450. All right, so this will break down into the square root of 450. And we will go ahead and figure out what our perfect square is. It'll go into it. So it'll be 1 and 450, 2 and 225, and right there, look at that. Ask and you shall receive. You guys see that right there is our perfect square for 15. Okay, right on our list there. All right, let's shoot back to it. All right, so I can go ahead and break it down. So again, remember that there are no numbers that are going to be lower than 225, so I can just stop. Once you get good at recognizing when you have a perfect square, it'll be a lot easier for you. All right, so anyway, so we'll break it down. Square root of 2 and the square root of 225. And the square root of 225 is 15, so this will just be 15 square root of 2. Let's keep going. All right, now you see here we have things on the outside and inside, so we're going to have to multiply them all together. So this, again, when you multiply the outsides, it'll be 3 times 2, so 6. And then multiply the insides together, it'll be 5 times 10 is 50, so square root of 50. And now we need to break down 50. So 50 is, I got 1 and 50, and 2 and 25, and there it is, right there. So square root of 2 and square root of 25. And the square root of 25 is 5. Now again, make sure you are multiplying these outside numbers. Let me rewrite it for you just so you guys know what's happening. Again, it's going to be 6 times the 5 square root of 2. And then multiply the outside numbers. It'll be 30 square root of 2. All right. Dividing radicals. Last thing. Again, in this case, what you're going to notice, guys, is that there's going to be a very specific thing that we have to do when we're trying to get the radicals out of the denominator. Again, like I said, it really does. It's not so important that you'd think that they can't be in the denominator. I could ask you to rationalize the numerator. It doesn't matter. Okay, but again, what you're seeing here is that the square root of a times the square root of a equals a. Now let me show you what that means. Now again, like if I did, let's say 6. So the square root of 6 times the square root of 6 equals the square root of 36, which is 6. So I can just go straight to 6 if I see this. This is what I'm looking for here. Whenever I multiply a radical by a radical and it's the same thing underneath, the radical just cancels out. All right, so that's what we're going to need to see whenever we're doing these kind of problems. So let's look at it. All right, so the first thing you want to do is reduce, and you don't necessarily have to reduce, but it'll make it a lot easier. So like in this case, you see I have the square root of 16 over the square root of 36. Now, these are both perfect squares, but if I reduce them, they're still going to be perfect squares. So let me show you. Again, they're both divisible by 2, so I can divide by 2. Actually, 4. Sorry, let's do 4. So divide by 4, and it'll be, again, and what you can do with this, if a fraction is all underneath a radical, you can distribute it kind of. So it's going to be the square root of 4 over the square root of 16. No, not 16. Okay, sorry. So it won't reduce quite yet. It won't be perfect yet, but that's okay. Oh no, over the square root of 9. Okay. Oh man, I need to go home. Okay, so square root of 4 over the square root of 9. Okay, I was right. We're good. Okay, and then the square root of 4 is 2, and the square root of 9 is 3. Okay, that's it. Now again, I could have just said, okay, taking the square roots right away, so square root of 16 is 4, square root of 36 is 6, and then divide these by 2, and I would have gotten the same answer. So it really doesn't matter, however way you want to do it. Let's go ahead and keep chugging along here. Again, if I can actually divide these out, which would be 81 divided by 27 is 3, I believe. Let's check, make sure. 81 divided by 27 is 3. Look at that. Okay, so this will just reduce into the square root of 3 right here. And that's just it. We can just leave it like that. Now, one thing you can do is you can take the square root of 81 on top. Square root of 81 is just 9. So it would be the square root, so it would be 9 over the square root of 27. And then in order to rationalize, what rationalize means is to multiply by whatever the bottom radical is. So again, I'm trying to get this radical on the bottom to cancel, so you're going to multiply both sides by that radical. Now again, the reason you do it to top and bottom is because you're trying to, you can't change it. You can't just do whatever you want. You have to do anything you do to the bottom, you have to do to the top. So now on top it'll be 9 square root of 27. Again, this is outside number, this is an inside number, so you just kind of smush them together. All over square root of 27 times square root of 27 is just 27. So now a couple things we can do, and again, you're like, how do you get 3, Shaw? I don't see it. Okay, so again, the first, 9 over 27 reduces to 1/3. So this will be 1 over 3 times the square root of 27. And we can break down the square root of 27. So again, factors of 27 are 1 and 27, and then 3 and 9. So this will break down into the square root of 3 and the square root of 9. Square root of 9 is 3. So I can rewrite it as 3 square root of 3 over 3. Again, that's just a lot of 3's. And then the 3's cancel. So you're left with the square root of 3. Now again, you see how much easier it was that I did it, the way I did it first. So again, reducing is going to help a lot, guys. So make sure you're doing that. Okay, let's keep going. So in this case, I've got 42 over 120. I notice that both of these are divisible by at least 4. Let's check and see. So I know, actually 6. So let's do 4. So I know that, actually, well, I don't need the calculator. So divide by 6 and divide by 6 here. So this will be the square root of 7 over the square root of, sorry, blanked out there for a second, over 20. And I'm going to go ahead and break this down now just to save us some time. So this is going to be the square root of 4 and square root of 5. And square root of 4 is 2. So I can rewrite it as the square root of 7 over 2 square root of 5. And then I can multiply. So now we'll rationalize to get rid of this one on the bottom. So multiply by just the square root of 5. Be really careful here, guys. Okay, on top and bottom. On top you get the square root of 35, which you cannot reduce, or you cannot break down, over square root of 5 times square root of 5 is just 5. Now we have to multiply by 2, so it's going to be 10. Okay, because again, there's 2 out here. You make sure you have to multiply by whatever that outside number is, and this will be your answer. Don't really have time to do this one, but if you wanted to real fast, you could just multiply by square root of 12 over square root of 12, and you would get 10 square root of 12 over 12. That reduces to 5/6. Square root of 12, we can break that down. into square root of 3, square root of 4, 2, no, not enough time. Simplify it. See you guys.